Hello everyone and welcome. This is the A+ Tutor. Today we're going over quadratic functions. Quadratic functions are functions of the form f of x equals ax squared plus bx plus c, where a, b, and c are real numbers. Additionally, when we see our quadratic functions in the form ax squared plus bx plus c, this is in standard form. The graph of a quadratic function is a parabola. So that U shape, whether it's facing up or facing down, is called a parabola. And whenever we see a graph with that U shape, that means it's a quadratic function. Let's dive a little deeper into the graphs of parabolas. When we graph a parabola, there are a few points we have to identify. First, the axis of symmetry. This tells us exactly where the parabola reflects from left to right. On the axis of symmetry, and the lowest point on our parabola is our vertex. Then, the place where our parabola intersects the y-axis is our y-intercept. And the place or places where the parabola intersects the x-axis are our x-intercepts. In this case, our parabola opens upward. This means our a term is greater than 0. Anytime our a term is greater than 0, we know our parabola opens upward. So let's look at the case where a is less than 0. When our parabola opens downward, we still identify the same features we identified when it opens upward. So this parabola has an axis of symmetry, a vertex. At the top of the parabola, the highest point is our vertex, our y-intercept, where the parabola intersects the y-axis, and our x-intercepts, where the parabola intersects the x-axis. In this case, our a term is less than 0, or our a term is negative. Let's walk through the steps of graphing quadratic functions. Remember, our quadratic function in standard form is f of x equals ax squared plus bx plus c. First, we'll find the axis of symmetry. The axis of symmetry can be found using x equals negative b over 2a. This will be a vertical line where the axis of symmetry exists. Next, find the vertex. We find the vertex by plugging in our axis of symmetry, or that x equals negative b over 2a, into our function. This gives us the y-coordinate of our vertex. Third, we'll find the y-intercept of our quadratic function. We do this by setting x equal to 0. Plug in 0 for x, and your solution is your y-intercept. Fourth, we'll find additional points to plot. We do this from our starting point, which is our vertex. We'll find the value of the function 1 unit right and left to our vertex, and 2 units right and left to our vertex. After finding all of these points, the fifth step is to plot these on the graph, connect the dots to graph our parabola. Lastly, we'll identify our domain and range of our function. The domain for parabolas will always be all real numbers or negative infinity to infinity. Remember, your domain just represents all possible x values for your function. For the range, we can find this even without looking at the graph. We'll be able to identify the range by using the a term in our function. If a is greater than 0 or is positive, then the function has a minimum value at the vertex, and our range is the y term of our vertex, or f of negative b over 2a, to infinity. So it starts at our vertex and goes all the way to infinity. If a is less than 0, or our a term is negative, then the function has a maximum value at the vertex. and our range becomes negative infinity to the y-coordinate of our vertex, or to f of negative b over 2a. Let's look at an example. Let's take f of x equals x squared minus 8x plus 13. Before we jump into finding the different features in our parabola, let's first identify our a, b, and c terms. A equals 1, b equals negative 8, and c equals 13. First, we'll find the axis of symmetry. We find this using x equals negative b over 2a. So we have negative 8 over 2 times 1, which is positive 8 over 2, which is equal to 4. Next, we'll find the vertex. We do this by plugging in our axis of symmetry, or negative b over 2a, into x and solve for y. This means we'll plug in 4 to our function. F of 4 is equal to 4 squared minus 8 times 4 plus 13. This equals 16 minus 32 plus 13. Combining our terms gives us negative 3. So our vertex is located at 4, negative 3. Now let's find the y-intercept, and we do this by setting x equal to 0. F of 0 simply gives us 13, so our y-intercept is at 0, 13. Next, let's find some additional points to plot. We do this by starting at our vertex, going left and right 1 unit, and then going left and right 2 units. So, starting with negative b over 2a plus or minus 1, we get x equals 5 and x equals 3. Let's plug those into our function and solve for those values. F of 5 is equal to 5 squared minus 8 times 5 plus 13, which is 25 minus 40 plus 13, which is equal to negative 2. Let's do the same with x equals 3. F of 3 equals 3 squared minus 8 times 3 plus 13, which is 9 minus 24 plus 13, which is negative 2. Notice how at both 5 and 3, we get negative 2 as our answer. Remember, the first thing we find is our axis of symmetry. Because parabolas are symmetric, the value of y, 1 unit to the right of our vertex, is going to be exactly the same as 1 unit to our left. So we can use this to save some time when we're solving x equals negative b over 2a plus or minus 2. We've just proven that at 6 and at 2, these will be the same value, so we only need to solve this once. So let's plug in 6. F of 6 is equal to 6 squared minus 8 times 6 plus 13, which is 36 minus 48 plus 13, and this is simply 1. So that means f of 6 equals 1 and f of 2 equals 1. So the additional points that we will plot are 5, negative 2, 3, negative 2, 6, 1, and 2, 1. Now, let's graph our parabola. First, we'll plot the axis of symmetry, which is x equals 4. Next, the vertex at 4, negative 3. Plot the y-intercept at 0, 13, and the additional points we found. Now, we'll connect the dots and view our parabola. The last step from here is to identify the domain and range. So remember, the domain represents all possible x values of our function, and the range represents all possible y values. The domain for our function, as with all quadratic functions, is negative infinity to infinity. For our range, our function starts at negative 3, which means this is the minimum value of our function, and goes all the way to infinity. So our range is negative 3 to infinity. Let's look at another example. F of x equals 2x squared minus 16x plus 33. In this function, a equals 2, b equals negative 16, and c equals 33. First, let's find the axis of symmetry. Remember, our axis of symmetry is x equals negative b over 2a. For this function, it's 4. Next, we'll plug in 4 to find our vertex. So f of 4 equals 1, and our vertex is 4, 1. Third, we'll plug in 0 to find the y-intercept. So f of 0 is 33, and our y-intercept is at 0, 33. Next, we'll find additional points by adding and subtracting 1 to our x-coordinate of our vertex, and adding and subtracting 2 to the x-coordinate of our vertex. Because the function is symmetric, the value at f of 5 will be equal to the value of f of 3, so we only need to solve this once. I like to use the smaller number because typically that's a little bit easier to plug into our function. So let's solve f of 3. F of 3 is equal to 3. Now let's do the same for 2 units right and left of our x value, which is 6 and 2. So we'll plug in f of 2 and get 9. Our additional points are 5, 3, 3, 3, 6, 9, and 2, 9. Next, let's graph. Let's start by plotting our axis of symmetry, plotting the vertex. The y-intercept will be off the graph, so I'm going to skip that, and our additional points. Connect these dots and we have our parabola. Lastly, let's identify the domain and range. Notice our vertex is a minimum value. It is the lowest point on our graph. Our domain is all real numbers, or negative infinity to infinity, and our range is 1 to infinity. Starts at our minimum value and goes to infinity. Next, we have f of x equals negative x squared plus 2x plus 3. A is negative 1, b is 2, and c is 3. First, we'll find the axis of symmetry. Our axis of symmetry is 1. Next, we find the vertex. And that is 1, 4. Next, we'll find the y-intercept. Our y-intercept is 0, 3. And the last step before we graph is finding additional points, keeping in mind that our graph is symmetric, so we only need to find f of 0 and f of negative 1, because then that'll also tell us f of 2 and f of 3. Now, let's graph. Plotting our axis of symmetry, vertex, y-intercept, and additional points, we can graph our parabola. Now, let's identify the domain and range. As for all parabolas and all quadratic functions, the domain is negative infinity to infinity, or all real numbers. This time, because our a term was -1, our graph opens downwards and we have a maximum value. The largest point in our graph, or the highest our graph goes, is 4. Therefore, our range is -infinity to 4. Let's take one last example. f of x equals -3x squared minus 12x plus 1. A equals -3, b equals -12, and c equals 1. First, we'll find the axis of symmetry. And the axis of symmetry is -2. Next, let's find the vertex. Plugging in -2 for x gives us 13, and the vertex is -2, 13. Now, let's find the y-intercept by setting x equal to 0. When x equals 0, we get 1, and our y-intercept is 0, 1. Now, let's find additional points. X equals -1 and x equals 3, which gives us 10. And x equals 0 and x equals -4, which gives us 1. So now we have 4 additional points to plot. Now let's graph. Plot the axis of symmetry, the vertex, the y-intercept, and all the additional points. Connect the dots and we have our parabola. And for the last step, let's identify our domain and range. Our domain is all real numbers or -infinity to infinity. Since our a term is negative and our function opens downward, we have a maximum value at our vertex, so our range becomes -infinity to 13. Thank you so much for watching. I hope you enjoyed. Please comment down below what other topics you'd like for me to review. I upload new videos every Tuesday at 1 p.m. See you next time.